Hello, today we're gonna be talking about electron configuration. So, first thing you need to know about the electron configuration is how to write it. So, for example, let's start with the element argon. How are we gonna be uh, writing the electron configuration? It's very easy, but you just need to do some memorizing to master it. There is one specific rule that we need to follow, which is the off-bounds principle, and it states that we have to go from lowest energy level to highest energy level, basically. So here is the order of each how you need to write it. So you go from 1s to 2s, 2p and 3s, 3p and 4s. We're gonna skip 3d over here, and then we go to 3d, 4p, then 5s, 4d, 5p, then 6s, 4f, 5d, 6d, and 7s, and then 5f, 6d, 7p, and 8s. So let's with this basic rule applied, let's now try to write the electron configuration of argon. So of course, as always, we start with the first, which is 1s, and what is the most amount of an s sublevel, most amount of electrons? 2. So we write down 1s2. What about for 2s? 2s2 as well. And now for 2p, remember that the maximum amount of electrons in a p sublevel is 6. So it's gonna be 2p6. Now, make sure to keep track of how much electrons you have used, basically. So here we can see, if we add the exponents, symbolize the electrons in each sublevel. So these are 2 electrons, and 6 electrons. That total to 10 electrons. And as we know, the atomic number symbolizes how much electrons are in the atom. So that means we have 10 electrons. We only need to add 8 more. Now let's go back to 3s2, and then 3p6. Now we have used all of the electrons. Those are all of the electrons. If you can see, that is 18 already. Now next is, how do you write it in a Bohr shell? So it's very easy. So first, you just put the symbol, the symbol thing, and then you write the amount of shells we have. So we have 1, 2, 3. We write 3, 2, 3. So remember that the maximum amount of electrons in the first shell is 2. So we're gonna write 2. Next, the maximum amount in the second is 8. Now, the third maximum amount, the maximum amount of the third shell is 18. But as you can see, we did not have 3D. So we just add together 3s2 and 3p6. Add together the exponents and you get 8. Now that is very easy. If you're keeping track, then I'm very happy for that. Now for the orbital box diagram. This one's a little complicated as well, but you just need to really master it to know. It consists of really simple rules. Let's start with the first. An S sublevel has 1 orbital. Each orbital has 1 box. So that means we have 1. This is 1s. Next, we put in the 2 electron in the orbital. One is clockwise and one is counterclockwise. Remember that. They cannot go on same direction. Now, let's go to 2, and then we do the same for the rest 2. Now, for 2p6, since we have 3 orbital, with 2 occupying each, we write down this 3 boxes for each orbital. Now, a key thing to note, a very neat thing that you need to note, is that you go by the direction first, each direction. You start with adding the clockwise and the counterclockwise. So yeah, that's 6, that's full, but that's something you really need to take note of, especially if the electrons are not full. So for example, if you get 3p5, then that is not full. You have to do, you don't just go like clockwise, counterclockwise, clockwise, counterclockwise. You go clockwise, 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 counterclockwise, counterclockwise, counterclockwise. That's basically the Hans rule for you. That's 2p, I mean 2p6. Now for 3s2, we do this pretty much the same with the first, since it's a complete. Now for 3p6, it's also complete, so we just write 6, the same thing. Now, that is complete already. Now, let's go back to the second one, to letter B, Bohr's shell. Since we are gonna find the valence electrons next, we're gonna see the final shells, outermost shell, amount of electrons, and that is 8. So, the amount of valence electrons is 8. And now, this one, valence electrons, it heavily correlates to the Lewis electron dot structure. So basically what you do in Lewis electron dot structure is that you put the symbol, and then you put amount of valence electrons clockwise, sorry. So you go by there, you're gonna add 1 dot each, so you don't just do 2 per side. If you have 4 valence, you need to go clockwise, then then clockwise again. So example, if you have 5, you're gonna be putting 1, gonna be putting 2, gonna be putting 3, gonna be putting 4, gonna be putting 5. It's not gonna be 1, 2, 3, 4, 5. That's wrong. Now let's go to, since the valence electrons is 8, we're gonna write 8 dots. Let's just complete this: 6, 7, and 8. And that is the the Lewis electron dot structure of argon. Now, let's find another element that we can do. Please give me a second. Let's do niobium 41. I don't know if you can still see, but hopefully you can. I will just zoom in it later. Let's do the electron configuration really quickly. Of course, you remember that the coefficient here is like the shell of where these orbitals are, and then the exponent means the amount of electrons in that sublevel. So let's start with the electron configuration of niobium. 1s2, 2s2, 2p6, 3s2, 3p6, that's 18. Then we go to 4s2, that's where we apply the off bonds principle. Since 4s2 is lower than 3D, we go to 4s2, then we go to 3D, 3D10. Now that is already 30. We go to 4p6, 36, 5s2, 38, sorry. We go to 4D, then 4D, 38, 39, 40, 41. So it's gonna be 4D4 if I'm not mistaken. Let us see. I'll just check. Oh no. Wait, hold up. Huh. How weird. Let's just go with this since what mom told us. There's slight difference in the Wikipedia, but we'll go with this one first. Let's see. Let's just add this with it. 10, 20, 30, 38, 39, 40. Oh yeah. So this is supposed to be 43. My bad. Since 41 is niobium, let's check now to hold on, to the Boyce shell. Now take a look at this, how it's incomplete. We're gonna be talking about that later. Boyce shell, we're gonna be doing NV 2, 8, 3, since it's complete, 18, 4, 2 plus 6 plus 3, 9, 11, oh sorry, and 5s2, that is 2. So that is the amount of electrons in each shell. Letter C, orbital box diagram. Let's skip the entire thing and let's go to straight to 4D3, since this is where we're gonna apply the Hund's rule. Since the D sub level has 5 orbitals, we're gonna put in 5 boxes. And now let's go to putting the electrons in each box. You need to distribute them per direction. So we first start with the clockwise. 1, 2, 3. And that is all of the electrons. 4D3. Since the thing is, even though it's incomplete, there are still going to be these are, notice how these are incomplete. You don't fill up one orbital each, you fill up by direction. So you go clockwise, 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 not clockwise counter, clockwise counter, clockwise counter, clockwise counter. So yeah, please make sure to know that. Now let's check the valence electrons from here. VE equals 2, and now let's just mark the Lewis electron dot structure. That is all.